So P10.5 part 2, some more examples, and these two are the harder two examples. So first of all we'll do the explosion, because that's a little bit easier. So let's say that I've got a rock, and I've got another rock here, and you drill into it, and you put some dynamite here, and you split this rock off in two exact pieces, 2 bits, and you know that the mass of this bit is 5,000 kilograms, and you know that the mass of this bit is 10,000 kilograms, and you know that the velocity of this bit is 100 meters per second. And you wanted to know how fast has that other bit gone off at. Now, you may have been able to work this out instinctively, because I picked really easy numbers, but we'll go through the maths and we'll show how we know we're correct with that instinctive guess. Okay, so first of all, the first thing we're going to say is the total momentum before equals total momentum after. Now, if you ever get a momentum question, just write that down, because there's nearly always a mark for it. From Key Stage 3 to GCSE to A level, if you say the momentum stays the same by writing something similar to that, there's usually a mark available for us on a momentum question. So let's pop those numbers in. So what do we get then? So the motor momentum before was mv1 plus mv2. And well, here's the interesting thing: it's not moving before it's an explosion, so we know that that's 0. Okay, a little bit easier. And then we know that afterwards we've got 100 times by 5,000, and here's something where we need to know a bit about convention. Anything to the left is considered negative, and it's to do with the fact that that's the way that we read and write. Okay, so we read from left to right. So this one has got a positive velocity, and this one has got a negative velocity. Remember, velocity depends on direction. Okay, so this one's got a negative velocity. So this has a negative momentum of 100 times by 5,000. Okay, so now I need to rearrange that to get B. So I'm going to move this to the other side. So I'm going to add this amount to both sides. Remember, it's add because it was a negative on this side, so it must be a positive on this side. And that's going to be 500,000. And that equals V. And then I'll take this 100,000 to the bottom. Sorry, 10,000 to the bottom. Cancel out my zeros, so I'm left with 50 divided by 10, which gives me, hang on, that's for all my zeros, 10,000 times by 100 is 1,000,000. So that should have been 5 million there, not 500,000. And I'll show you how I knew I just for all my zeros in a second. Which means that I've got 50 meters per second. And the reason why I knew I'd done for all my zeros was because I knew I was expecting a velocity of half of this, because my mass is twice as big. So the momentum to the left was the same as the momentum to the right, and if my mass is half the size of this side compared to this side, I know that the velocity is going to be half the size of this side compared to this side. Okay, next one. This one's the hardest problem that you can do on momentum, and this is to do when you've got a head-on collision with two vehicles going in opposite directions. So let's say we have a van and we have a bigger van. lorry. Okay, so this one's going this way, this one's going this way. This one's travelling at 20 meters per second. This one is travelling at 10 meters per second. This one weighs 1,000 kilograms. This one weighs 20,000 kilograms. Okay, so when they crash head on, what's going to happen? So, same thing that we do every time when we start one of these questions is we say that the total momentum before equals total momentum after. We always do that. What is the total momentum before? Well, we have to remember our convention from the last example. So this one is going to the right, so this one has got positive 20, and this one is going to the left, so this one has negative 10. So our total momentum before is going to be 20 times 1,000 minus 10 times 20,000. And the reason why it's minus this time is because that is going to the left, and that momentum is cancelling out this momentum. Okay? And that will equal the total momentum after. You can write that however you wish. I've used TA this time. So, total momentum after. Okay, so, and let's say that they join together when they crash, and I want to find out what the new velocity is. I'm going to say that m1 add m2 times by the velocity after is going to be equal to all of this. When I work that out, so that's 20,000 minus 200,000. Okay. So that means, and I know that my two masses were 1,000 and 20,000. And that's going to equal minus 180,000. And then I can do rearrange that, so VA equals 180,000 all divided by 30,000, and that will give me, cancel out my zeros, 18 divided by 3, remember it's a minus, so that's going to be minus 6 meters per second. So what does that mean? That means that both the lorry and the car will be going to the left together. So basically, they've come in, they've crashed, and this one has taken it with it. Okay, and the reason why it's taking it with it is because its mass is so much bigger than this. So remember, it's a combination of mass and velocity. But this one's mass is so much bigger, which took it with it.